No, can you do the screen sharing? Michelle, can you switch to the screen sharing application, or I can do it? All right, so salam alaikum. This session is going to be about enabling DNS over TLS, and it is. So this session is going to be about enabling DNS over TLS, and we'll show you how easy it is. So first, some bits about me. I'm Gerry. I'm just someone, as Hiba. So is this going to work? So I'm just someone, as Hiba just said. I work for Tichon, which is a small ISP in Belgium. I'm also self-employed, and I'm one of the main organizers for the Boston conference in Belgium. So a quick overview of what we'll be talking about. Some of these things are a bit redundant because, well, they've been mentioned by Mo and Sarah before, but we'll go over them quickly. We'll then go on with what is DNS over TLS, why do you care, and how can we use it. We'll also show you some examples. Okay, thank you. And after that, we'll have a small demonstration. So really quickly, why do we have DNS? Because, well, we want to map host names to numbers. I just want to point out that DNS is a really, really old protocol. It's been in use since the early 80s, and it actually predates the internet as we know it today. It's been drafted for the first time in 1982, and the first actual implementation was the bind name server in 1984. So it is really, really old. The basic concept is a distributed system with a tree structure, a directory system, and the idea was that it would be resilient and consistent. So those are were the main ideas at the time. There's three main components. So of course we have the data, which are the zone files and the resource records, etc. We have the name servers, so the authoritative name servers, if you want to call them that way, and the resolvers, or the recursors, or recursive resolvers, however you want to call them, which are the servers your laptop is likely talking to. DNS is a very simple protocol. Well, it started off as a very simple protocol. It is running over port 53 using UDP. Why UDP? Because it's fast, low overhead. It's a single request, a single reply. It's really simple, actually. And the message format, well, I've put it there for informative purposes. But just to show you that there's lots of information in any given DNS packet. So we have, of course, the header. We have flags that tell you the type of request, how it has been answered, how you want it to be answered, etc. And then, of course, we have the question. And if the packet was an answer, you will also have the answer in there. One of the main issues is that when DNS was designed, privacy was not a concern yet. So the internet was really small. It was only a couple of 100 hosts maybe, and everyone trusted each other. So this is a simplified diagram of how a DNS request works. You've seen similar diagrams in the previous presentations. But so as you can see, the client talks to the resolver, and this is actually the part we're going to talk about today. This communication is all in the clear. So as you can see, the client asks for an A record for quad9.net to the resolver, and the resolver will reply with the IP address. Now, the actual packet, as you can see, well, I mentioned it before, there's lots of information in here. You can see what we asked for, who we asked it to, and the different flags that were set. And this is the answer. So the answer will also contain the original question, in addition with some more information even, also containing the answer. You can see it's, well, the answer is at the bottom there. I don't know if you can read it really well. Now, the problems with this is that you don't know who actually saw your question. So as Sarah said, the traffic can be intercepted by anyone listening. You're also not sure who answered your question, since DNS is usually run over UDP. So the reply can be spoofed. You don't know whether the answer is actually correct, so you don't know if it has been tampered with. And basically you don't know at all what happened to your packet. Now, we're going to try and solve part of this by using DNS over TLS. The idea is to wrap plain DNS queries and answers via the TLS protocol. A basic overview of how it works. It will then send a normal DNS query and receive an answer over that TLS session. If you want to know more about it, the interesting details are in both of these RFCs. So a few problems it actually solves. There's the interception problem. So anyone listening to a DNS over TLS query and answer will not be able to see what your question was or what the answer is. So that resolves the privacy issue. And you will also be sure that the answer you got back from the resolver is actually the answer that was sent by the resolver and not by someone listening in between. There's also some other bits it solves, like, for example, since it's running over TCP, it is not as vulnerable to the DNS amplification attack that we've heard mentioned before. It is not a silver bullet, so it will not solve all of the problems with DNS. So, for example, what it will not solve is any kind of interception between the resolver and the authoritative name server. So the resolver will still need to query authoritative name servers on the internet. That traffic will still be in the clear. It will contain less of your personal information, but it will still happen, of course. Then there's also the possibility of tampering between the resolver and the name server. It is a bit far-fetched, but it could technically happen. And of course, the resolver you're using, even though you're talking using the TLS protocol, the resolver itself could be malicious and could be modifying modifying the answer before sending it. And then obviously, whatever you do with your answer after you had it from the resolver, if you then go and set up an HTTPS connection to a website, for example, your browser will send an SNI header, and that will, of course, still be in the clear. So be aware that it's not a silver bullet. And of course, it's also not a replacement for DNSSEC, because what you have solved here is the communication between the client and the resolver, but you still don't know whether the answer you got is what the owner or the hostmaster of the domain you're querying is, well, if it was what he intended to be. So why would you want it? Why do you as a user would like to use DNS over TLS? You don't want anyone to listen to your traffic. You don't want anyone to modify the replies. There's many possible issues you can have if that happens. You know that the answer you got back is has been sent by the resolver that you are talking to and that you trusted. And any party between you and the resolver will not know what the query was. So how can we start using it? It's rather easy, actually. There was some discussion earlier about the possibilities of running local resolvers on your machine, whether or not you should use a resolver with those. But anyway, one thing you could do is set up a local resolver, be it on your local machine or within your own network, if you trust your own network, of course. I hope you do. But you should, of course, be aware that any traffic between your stub, so your local resolver, between you and your local resolver will still be in the clear, because, of course, the encryption will only happen after that. So one idea is indeed to run it on your local machine, and that's what we'll look at in a minute. Or if your device supports it, you can just enable it. Android P and Up has it enabled by default if the resolver supports it. I'm not sure what the status is in Apple iOS. There were some indications that there were some code paths there that could be used, but I'm not an Apple user, so I don't know. Looking at my fellow troublemakers. No. And I sure hope that we'll see wider support soon. So this is a screenshot of the setting as it is in Android. The default is selected here, so the default is automatic. Android will try and resolver supports DNS over TLS and will then use it. As far as local resolvers go, so software you could be using on your network or on your machine, this is a non-exhaustive list. There's many more, well, a few more. We'll be looking at the first two, so we'll see what the configuration is like for Unbound and for Stubby. If you want to start using it, you obviously need a resolver that supports it. So on dnsprivacy.org, there's a full list of operators. I've mentioned the two more prevalent ones here. The first one is Quad9, who we all know and present in this room, and I hope we can all agree that, you know, they're good people. And then there's also Cloudflare. So how does DNS over TLS actually work? I've modified the previous diagram somewhat. As your client will be talking to the local stub resolver using regular DNS, it will not see any difference. But then from the stub resolver, you see that the communication is encrypted to the resolver here. So this is exactly the same query as the one that I showed before. As you can see, the data is illegible. It is fully encrypted, so no one knows what your question was here. Same thing to read there. So we'll do a quick demonstration as well. We'll look at a basic configuration of Stubby and Unbound, and we'll run a quick test with KDIG, and we'll do a live capture in the meanwhile, and I hope this goes well. So what I've got here is a virtual machine running two name servers. I've got a live capture right here next to it. We'll see if it works. So first, I will do a normal DNS request. So this request is a plain text DNS request. As we can see, we have an answer. Come on, update. Oh, of course, this fails. Just a second. Yes. Right. So I have it on my laptop already. Wait a second for the screen to update. There we go. So what I did here is I ran a normal DNS query. I asked the Quad9 resolver directly. And as we can see here, there is an answer. Come on. So in the packet capture, let's wait a bit for the screen to update. We can see that both the query and the answer are plainly visible. So the Wireshark capture is actually running in between the virtual machine and the local network. So I'm actually looking at traffic that your ISP could see, for example. If we now do the same thing using DNS Server TLS, we should see that here. There, let's wait for the screen to update. So this is exactly the same request, except that I'm using DNS Server TLS. As you can see here, I have enabled the debug flags. Come on. Come on. So here you can see the TLS session being set up. What is actually happening? You can see the certificate that's being used, and then at the bottom you will see that the answer is exactly the same. On the right side of the screen, we will now see that both the query and the answer are completely illegible. So if we look at the data, for example, here we go. Let's wait for the screen to update. There. So you can make nothing out of this. If we then look at how we can start using it, so I've installed both Unbound and Stubby on this machine. The configuration lives where it usually lives. There we go. So what I've done here is I've pointed my etcresolve.conf to my local host, and I have got the Unbound resolver running on my local interface. I will move this a bit towards the middle. There we go. So as you can see, the configuration required is really minimal. I've just pointed Unbound to the certificate store installed on my machine, and I have configured it to use DNS Server TLS. I've pointed it at the Quad9 name servers, and that's all I have to do. So now I can just start using it, and all my DNS traffic will be properly encrypted. That was there. So as you can see, the only name server I'm currently using, these two are commented out, is my local host. So if I run a regular request, there we go, we can see again that it's, well, in a minute, we can see again that it's all encrypted and my machine is, using DNS Server TLS properly. The same thing goes for Stubby. So if we have a look at the Stubby configuration, it's fairly similar actually. So I've configured Stubby to listen on my local interface right here. I have also instructed it to use TLS query padding, so you can't even see the size of the actual DNS request. And I've configured it to use the Quad9 DNS server right here. An example here below is configuring a static SHA-265 hash, 256 hash, which is something you should not do. I would recommend you use the local certificate store instead. So this is a good example for stubby. Now, well, some things went wrong. For completeness sake, I will also mention some alternative technologies. These are different solutions to the same problem. I don't think they're all that much to look at. Well, some of them. There is DNS over DTLS, which is fairly similar, except that it will use a datagram instead of TCP. There's DNS over HTTPS and DNS over QUIC, which are both similar to each other, but I don't really know why you would want that. And then there's DNS Crypt and DNS Curve. But not all of these have actual implementations. Some of these are just ideas and concepts. I would suggest you simply enable DNS over TLS with the Quad 9 resolver, of course. So thank you for listening. I will take questions if there are any.
We have two questions in the remote participation from Samir. The first one is, enabling TLS communication will add overhead and delay to the connection with DNS. How can this be faster than my provider DNS?
Well, so first of all, you will be, well, your provider's cache is probably not even as fast as Quad 9. So yes, you will have some over, and you see a measurable difference. Maybe you should go and talk to your provider to provide better connectivity to the Quad 9 node instead. And also, I think your privacy is worth maybe a couple of milliseconds, no? Yes?
Thank you for that presentation. Was good. This Kevin. So my question is from a user perspective. So, for example, if a common internet user, this someone, average internet user wants to have this implemented, is this something that, for example, let's say I'll go back to the university network I used to work for, ISP that used to support university network. What is the implementation infrastructure that needs to be set in? So if I want to have this implemented in my network, for example, for the common internet user, is there a way they can verify that yes, my DNS query is being protected in a way? Is there a way I can somehow verify that? And how long would it take a network administrator to do what you've done in terms of setting up an encrypted secure TLS? How long would it take?
Right, so there's a number of questions. First, your question about whether the user can know whether their query has been, encrypted using DNS over TLS. I'm not actually sure if you could find out. I don't think you can. I can't think of any creative ways you could. But as a network operator, you say you're running a university network. I'm going to assume you use some sort of sane local DNS caching resolver. So let's say, for example, you use Unbound. The configuration I showed will work for any number of clients. So if you just enable this bit of configuration on your local Unbound resolver, all the queries from your students will be encrypted past your network. Of course, they will still run in the clear over your network, but I hope you trust that one. So I think the most important bit is that the traffic over the internet will be encrypted and not be visible to your providers.
Hello, from the trouble. Okay. Yeah, well, the local resolver that I was mentioning before with the centralization thing, I'm running stubby on my MacBook and talking to the recursive resolver in my lab over DNS TLS. So that works in practice. It's not just talking the talk, it's also walking the walk. But what I think you forgot to mention is that, and I was testing this lately, Android 9 implemented it, and interestingly enough, it's on by default. So you can go in there and actually, so I got some information from the secret things that says if it's automatic, then it does not verify the certificate by name. So it's opportunistic encryption. If it's a private DNS provider hostname that you enter the address name there or the DNS name there, then it verifies if the certificate is valid. But the most important thing is that if you enable it, if operators enable this function on their recursive servers, Android users will just start using it automatically and be done with it. I think it's an important step in configuring this stuff. Thank you.
All right, thank you. I did not know it was opportunistic encryption, but that's very useful information indeed. And glad to hear that it's actually working in the wild as well for you.
We have another question from the remote participation. Abdurrahman Hussein, he's saying, what exactly is the benefits of using the stubby?
So the question was what the benefit was of using Stubby?
Yes.
Okay, so it doesn't really matter which software you use, whether you use Stubby or Unbound or Bind or not Resolver, it doesn't really matter. They all do the same thing. The main takeaway from this should be that, as you've seen in the previous presentations, people can learn a lot about you. They will know when you're using the internet, they will know what sites you're visiting, and they will know at what time you're visiting them. That is incredibly useful information for advertisers, for any sort of company interested in your data. And from my point of view, you should do everything to protect that information. One tiny thing you can do is start using Quad 9 with DNS Server TLS to hide your DNS queries, and it will bring you some additional benefits as well. So the main reason for using this is actually, well, for me, it would be to protect my my private information. I don't want people to.
Another question in the remote participation. I'm not sure if I understand this well or not, but it's from Mazin. He say, if I have DNS in another country and I really have DNS in my country, how this works in my phone? And I think he's asking about whether having the forwarder of the DNS in another country, this will affect his performance or something.
Right, so I'm going to assume he's already using a DNS server in another country. If he's not, maybe he can talk, well, maybe there's a bit of overhead. There's the encryption that needs to happen. Your computer will take a few CPU cycles to do that. The resolver will need a few CPU. And it is likely to be even faster than your ISP's local cache. So I would say give it a shot. And if it's a couple of milliseconds per DNS request, if you are using a local cache, such as Unbound or Stubby, you will only have to ask each question one time. Usually when your computer wants to go to duckduckgo.com, for example, you will solve a bit of that problem because it will actually be caching for you. So you'll only have the performance hit once, and I think it will be a minor one. Any more questions?
Would you just give us a brief introduction about the technologies that has been used for DNS? That's been used.
What sort of?
A brief
What sort of introduction are you looking for? Do you want to demonstrate? Oh, okay. Oh, okay. Right. Yeah. So you're asking about the technology we're using to encrypt the packets, right? Sorry, I didn't understand that. So it is just plain standard TLS. So it is the same protocol you're using when you're using HTTPS, for example, these days, it is just standard TLS. It's nothing magic. So it's basically running DNS over TLS, as the name says.
Very recently did something that upset a few people in the internet community. Can you tell us a little about that? I realize it's not really related to your presentation, but it might be an interesting story for people here. Somebody did, so they used an alternate technology, the DNS over HTTP.
Right. I mentioned in the slide with the alternative technologies, there's a few of them. One of the main DNS providers on the more widely used DNS providers on the internet today is Google with their name servers. They have implemented an alternative technology, which is DNS over HTTP, and they have implemented this in their browsers. Now, I see several problems with that. The main issue I have with that is why would you want your browser to do your DNS resolving for you? Your operating system is perfectly capable of doing that already. Why do you need more software that duplicates functionality on your computer is beyond me. So I think they may have tried to do a good thing there, but I think they ended up implementing it wrongly. So they seem to want to centralize all this functionality in your browser. Your browser is already doing 1,000,001 things. I don't see why it needs to do DNS as well. So I would not be too happy for that to be running on my computer personally. Yes, indeed. And then we come back to the architectural discussion we had earlier. So if some of you want to discuss this further, I will be happy to join the discussion after lunch, so we can